So, for instance, where we want to find the limit as x approaches -3 of this rational function. Can I use direct substitution? Why not? I wind up with 0 over 0. I wind up with something that's called the indeterminate. Indeterminate meaning we still haven't determined, there is an answer, but we haven't determined what it is. 0 over 0 doesn't give us enough information. There are multiple techniques out there to help us find the limits. One of them is using derivatives, which those of you going to calculus will find out about those. Another two that we're going to be looking at today, one of them involving dividing out. So, again, this is when our direct substitution, the easiest thing. When it doesn't work, we can use our dividing out technique. So here's our limit again. First things first, factor. Take a look at your numerator, take a look at your denominator. These polynomials, can we factor them? So can I factor my numerator? To what? So here we have factored out our numerator, x plus 3x minus 2. So step 2, divide out any common factors. What are my common factors here? Absolutely. Simplify. So now I have the limit as x approaches -3 of what? X minus 2. And now what do you think we do? We just use our, now in this case we can actually use our direct substitution and then simplify. So using my direct substitution, what do we get? Absolutely. We wind up with a limit of -5. It started off at 0 over 0, but once we use this technique, we actually found that the real limit is a -5. Okay. So, let's try this one. Step 1, can I factor it? In particular, when you're doing these type of problems, and direct substitution didn't work out and you think there's going to be something to factor, if you tell you to factor in the numerator denominator, use that as a cue. Perhaps one of those factors are going to be in my other one, the numerator denominator. So, like in this case here, if for some reason you're struggling with factoring out that numerator, it's a good chance that one of those factors would have been x minus 2, right? So, step 2. Divide out those common factors, leaving me with the limit as x approaches 2 of x plus 4, which gives me an answer with my direct substitution of. This stuff's easier than yesterday, right? Yeah. The limit of this rational function as x approaches 2. I know the tough one is factoring that numerator, so we'll save that for later. What about that denominator? It is a simple factor. So factor by? Yeah, absolutely. When I have 4 terms, ask yourself, can I factor by grouping? If you could not, in this case we can, we'll take a look at that. If you could not factor by grouping, what would you have to do next? We'd have to do all that stuff we did before with finding those zeros using our synthetic division, right, using discards or finding your possible rational zeros. From there, you'd be able to factor it out and do whatever have you. But in this case, my denominator, which means that we can do our factor by grouping. Look at the first two, and then look at the last two. So what can I factor out from the first two? And Gil, what about the second pair?
2.
Absolutely. So here we can see we do have that common factor now that we can pull on out, our x minus 2. Leaving behind what?
X2.
So this is my denominator. Davin says I can play Zorro here or something. Is that what you're saying? No? That's right. Divide out those common factors. Absolutely. Using my direct substitution, as Alex said, we get that 1, 6. Questions on that? Limit of 5 minus x over x squared minus 25 as x goes to 5. Kyle, what can I do here? We don't really want to square root, but can I factor them? That's a difference of what?
Square.
That's a difference of squares. So I get what? X minus, and absolutely. And my difference of squares, I get that. Do I have any common factors? No. As it stands right now, I have no common factor. Can I do something to make it? What do I do?
Take out a negative.
Absolutely. Here we can see, if these signs were reversed, I would have a common factor. So I'll instead take out that negative. When I take that negative out, I'll have a negative 5 and a positive x, or written as. Now, my common factors, x minus 5 cancel. I'm left with the limit of a negative 1 over x plus 5 or x. Question. Sometimes the dividing out technique does not work. Direct substitution does not work. In particular, if we had something like the limit of 1 plus x to the 1 over x as x goes to 0. Why can't I use dividing out? Nothing to divide out. Direct substitution won't work because so here's where we can rely on our wonderful technology, our calculators. So, just doing our graph, what is it, 1 plus x to the 1 over x. Everybody should be doing this. here we get ourselves a wonderful looking graph. But looking at the graph is not going to give you that answer. It's not going to give you the clear fidelity you're looking for. Again, sometimes there's gaps, holes, or there may actually be some oscillations that we don't see. The best thing to do is look at the table of that graph. So we can do Control T for the table. As x approaches 0, if I looked at this, I'd say it's approaching 1. 1, 3. As x approaches 0, it says I have a y value of 1. But this is not the case. We do not want to look at those integer values. We want to look as we get closer and closer to 0. So I want to look at something like 0.001, negative 0.001. So what we do is go to our menu, Table, and then Edit Table Settings. In the first part where it says Table Start, that's where we want to have what x is approaching. It's always going to default here to 0. And in this case, we're looking at the limit as x approaches 0, so that's perfectly fine. Down here in Table Step, again, we don't want to look at the integers going from 1 to 2 to 3. Instead, we want to look at something a little bit smaller. So change that to 0.001. So now you'll be looking at really, really small ones as we get closer and closer to our limit. So by doing that, right, and using our up or down key, I want to look again. The limit as x is approaching 0 from the left and from the right. So from the left, right, when I have my x equaling 0.002, 0.001, I can see the values 2.72, 2.71. Coming from the right, 2.71, 2.71692. So what is my limit? How am I going to calculate that limit as x approaches 0? Absolutely. Take the average of my 2.71964, 2.71962, basically what? 2.718 or something? You guys have the calculator. I know I have a big one here too. So, roughly we wind up with at the limit as x approaches 0, in this case it would be 2.718. Again, don't look at those integers. If I'm looking at as x is approaching 0, looking at 1 and negative 1, it's not really going to give you the information you're looking for. You want to get that clear fidelity by taking, perhaps setting that step to 0.001. Don't forget also, if it's something other than the limit as x approaching 0, we want to change that first number. If it's the limit as x approaches 7, 6, change that to 7 or 6 corresponding. So, here we have the limit of 1 minus cosine of x over x as x approaches 0. Can I use my direct substitution? No. Well, that doesn't work. I get 0 over 0. What about derivatives? Yes. But you guys don't know that yet, so pass that one. So you're doing a calculation, tell me all about it. So instead we can use our, that's actually easy. So here using our technology, we want to graph this. So I want to see everybody graph it.
I didn't do it. I didn't do it.
How do you what? How do you do what, Reed? Reed. How do you, oh. We can get rid of this again with Control T, get rid of that table. And then also by selecting your graph. And then hit delete. Just hit the graph and hit delete. Right? So you don't have them on, and then just again tab brings it back on up. The tab. So now we have what? 1 minus cosine x over x. Remember, folks, we are not looking at, just making sure you guys are paying attention. What's that? So what do? We hit the Control T for our table. Now what? So here we can see In this particular one, we could have actually seen that straight from the graph, but again, you don't know what's going on with that graph just by looking at it. Some small little nuances can be happening there, so looking at the table gives you a more precise answer. So here we can see right around as the limit as x approaches 0, we take the average of that 0.0005 and negative 0.0005, giving us an answer of, I was going to say 42, but 0 works as well. Absolutely. Questions on that?
So we always do, for the table start, do we always do 0?
No. Remember what I said? Exactly. In this particular case, right, let's say that here it said as x approaches 2. What would we do? Well, in this case, we just plug it in. Just direct substitution works, right? But if it was something where we wanted to graph it, here we would, on that table, we would change that starting point to a 2. We would not leave it as a 0. So, good question. And here we have the limit of sine of x over x as x approaches 0. We're not looking at that actual number at x equals 0. We're looking right around it, taking that average. In this case, you just wind up. Question? Tough stuff. You can hit Control T again. Just like you did Control T to bring up the table, Control T will also get rid of that table. And then you can also just select the graph. Delete the graph so you don't have those multiple graphs on there. Oh, I didn't ask. You guys want to practice something? Okay. So, we'll do some more examples. You guys said you didn't want to practice.
Homework, yes. The homework is what you're referring to.
Well, I just said practice. Whether or not that's homework. Okay, so this side does not want to practice.
I would like
You
to
guys want to practice?
practice.
I'll let you guys practice. Everyone else can get your homework later. You guys sit in that practice. And Maddie's taking 3 on this one. Round one. You guys ready to do some? No, that's good. Oh, was it Chris to read?
How do you show words for these?
Also, make sure you do make this correction here.